Hi, I'm Carlotta Berry, and I'm a professor in the Lawrence J. Giacoletto Endowed Chair of Electrical and Computer Engineering at Rose-Hulman Institute of Technology. I am also a professor of robotics and an open source hardware trailblazer. So today I want to give a perspective of who I am as an academic and how I feel that academics can engage in open source hardware in an effort to do their scholarship, their teaching, their diversity, service, research, as well as professional development. So Ernest Boyer states that the work of the professoriate may be separated into four separate yet also overlapping functions, including scholarship of discovery, scholarship of integration, scholarship of application, and scholarship of teaching. He proposes that there must be a more inclusive view of scholarship where these four dynamically interact to make an interdependent whole. I postulate that it is possible to use open source hardware as well as robotics in order to do this new kind of scholarship. And the way that it happens is because knowledge is acquired through research, synthesis, practice, and teaching. In particular, at a school like where I work, which is an undergraduate engineering education institute, and our highest degree awarded is a master's degree, and most of our master's students are course-based. So therefore, I engage mostly in my scholarship and professional development and research work with undergraduate students. So in order to do this work with these students, there has to be a new paradigm shift of a perspective of how I'm able to engage with them. And it's by recruiting them to do this type of work when they take my courses. So as I'm teaching them in a robotics course or a controls course or circuits course, signals and systems, I integrate into that course a little bit about what they could do with this knowledge, where there's real world application, in order to recruit them to get excited about seeing some of these practical applications by doing research with me. Obviously, it makes more sense to do this in an open source framework because you're trying to bring in a larger community. Because also with undergraduate students, it's going to take a little bit longer in order to get impactful results that are publishable, or maybe some results that you could write a grant to get. So by working in a community where you share these resources and publicize this work, it's easier to do that. So thinking about that, the scholarship of discovery, the scholarship of integration, the scholarship of application, and the scholarship of teaching can all be stacked on each other, and they work as this interdependent whole, where the scholarship of discovery is your more traditional investigative research. But in order to get there, you may want to use a connection across disciplines, which robotics is also great for because it's inherently multidisciplinary. And you may also look at the scholarship of application, such as helping your students to understand, as an engineering student should, where their work would be applied to consequential problems or service in order to improve society. And of course, on top of all of this is your scholarship of teaching, where you're educating and enticing future scholars to transmit, transform, and extend knowledge. But you're doing all of these not in these separate silos, but you're doing it all together in order to make that impactful change. So this discovery expanded my vision of what engineering education can be, where I'm no longer solely looking at education, research, or outreach, but I use them to all inform each other. And the great thing about the outreach and the service is that's a great way and a great recruiting tool to bring more diverse populations into STEM, into engineering. So you're also working on seeding that pipeline in order to get more people excited, because then once they're in that community, you then can excite them to do undergraduate research or do independent study or go on to more advanced courses in a topic like robotics and controls. And then from there, you can build onto that in order to look at them doing some of the professional development work that an academic would need in order to write grants, publish papers, or graduate undergraduate, master's, or PhD students. And in my case, that's human-robot interaction, heterogeneous teaming, or supervisory control. So the great thing about all of this is that because robotics is multidisciplinary and multidimensional, I can teach with robotics, I can do service and outreach with robotics, I can use robotics for professional development and research, and then I can use the results of that to inform back into my service as well as my teaching. And that's really what my platform is as an open source hardware trailblazer, to look at robotics for the streets, using robotics to make STEM more inclusive and accessible to many different people, while also helping the academics to meet their professional goals, as well as maybe service could be considered personal goals as well. And so I call this being a nowhere STEMinist, because I also like to integrate this STEM with diversifying people, with teaching, with outreach and robotics, and marrying all of these things together in order to do this open source hardware. So I hope you will come back to visit my blog posts, my video blogs, Instructables, Hackster, my social media posts, because all of these together create this guidebook that I hope to use to show academics that it is possible to engage in open source hardware. And then towards the end of my year, I want to use the platform that I have created to share with some academics in the community and have you follow through some of the lessons and things that I do with it and give me feedback on what you think. Is this something that is viable for you to be able to use to meet all of those professional goals that you have? Thanks, and have a robotastic day.